In this video, we want to practice using our properties of integrals. So we've been given one integral, the integral from -2 to 3 of g of x. dx is 4, and we're going to use that single integral to help us compute some additional integrals. So for part A, notice that we're integrating from 3 to -2. So our limits of integration are in the wrong places because we want the lower limit of integration to be the smaller number. So this is an easy fix. Remember, with our properties of integrals, we can change our limits of integration by multiplying by a negative. So if I switch the bottom limit of integration to be a -2 and the upper to be a 3, then I will just multiply this integral by a -1. And again, the integral that we were given here, the integral from -2 to 3 of g of x dx is 4. So therefore, we know the value of this integral, and that's going to be 4. So this is going to be -1 times 4, which ultimately leaves us with -4. Part B, we're integrating from -2 to 3, so the limits of integration are in the right places, but we are integrating 5. So this actually doesn't have anything to do with the integral of g of x that we were given because we're integrating a constant. And we do have a property for this, but I just can't help reminding you to visualize when we have a constant function such as y equals 5, we just have a horizontal line. So imagine you have your horizontal line of y equals 5, and you're wanting to integrate from -2 to +3. So I think it really helps to visualize that region, the area between this horizontal line and the x-axis. And that's just going to create a rectangle. So this integral is essentially asking us just for the area of this rectangle. So using a little geometry, the base measurement here would be the distance from -2 to 3, which is a distance of 5. And then our height here, because our horizontal line was y equals 5, that would be a height of 5. So we're basically just going base times height, which is 5 times 5 is 25. Now I know this video is supposed to review properties of integrals. I just can't resist the opportunity to remind you what the graph looks like. But yes, we do have a property for this. And the property we could also use is that if we're integrating from a to b, a constant, then we are essentially multiplying that constant times the difference between a and b. In other words, the constant times b minus a. But again, looking at the picture really may help you understand this formula because the constant here, that essentially is just the height of that rectangle. And then the b minus a here, that's how we essentially got this distance of 5. So you could also use the formula, of course, and just go 3 minus -2, which is a result of 5, and the formula would work as well. Part C is the integral from -2 to 3 of 5 plus 2 times g of x dx. So first off, our limits of integration are in the right order, so that's great. They match the limits of integration that we were given in the original integral. And on this one, we have a sum, so we can use our sum property that essentially allows us to integrate separately. So we'll integrate from -2 to 3, the first term, which is 5 dx, plus the integral from -2 to 3 of 2 times g of x dx. So we're going to compute two separate integrals. Then you'll notice for the second integral, we have a constant times a function. So that's our constant multiple rule, very much like our constant multiple rule with limits as well as derivatives. So we can pull that constant out in front and take 2 times the integral from -2 to 3 of g of x dx. So now looking at the first integral, we've got the integral from -2 to 3 of 5. So we're back to that constant again. And you could visualize this, or frankly, you could look back and go, we just did this integral. It ended up creating a rectangle, remember, with a base of 5 and a height of 5. So we can steal our work from earlier. No sense to recreate the wheel. We know that's going to be 25. Then we have plus 2 times this integral. But again, this integral from negative 2 to 3 of g of x dx is the integral that we were given. And we know the value of that integral is 4. So that's going to be 2 times 4. So 25 plus 8 gives us a final answer of 33. Our next example, we're integrating from negative 2 to 0 and then from 0 to 3. So look closely at these limits of integration. And if you were to think of a x-axis or even just a number line, we're going from negative 2 to 0 first off for the first integral, but then we pick up at 0 and then we finish at 3. So that's essentially the same as integrating all the way from negative 2 to 3. So we can use our property, which allows us to combine these two integrals into one and integrate all the way from negative 2 to 3 of g of x dx, which is the integral that we were given. And again, we know the value of that integral is just 4. Here's our last one. We're integrating from negative 2 to 5 of g of x dx and then subtracting the integral from 3 to 5 of g of x dx. And I think it's easiest to demonstrate this one by thinking about what a graph might look like. Now, I have no idea what the function g of x actually is, so I'm just going to graph something random here for g of x. But let's visualize if we're integrating from negative 2 all the way to 5. So the integral from negative 2 to 5 would be this region here, the area of this region. But then we're going to subtract off the integral from 3 to 5. So if we look at the region from 3 to 5, 3 to 5 would be this region here. So think of it as the black area, the area of the black region minus the area of the red region. So you can see then what's going to remain would be this region here in green, which would be the integral from negative 2 to 3. So since we are subtracting here, this will be equivalent to the integral from negative 2 to 3 of g of x dx. And again, that's the integral we were given, and we know that value is 4.